Welcome to The Explainer. Today, we're diving into a genuinely fascinating framework in the world of multi-cloud cybersecurity. Now, if you've ever found yourself wondering how on earth modern organizations defend against these massive, coordinated cyber attacks across totally complex cloud environments and do it without completely sacrificing data privacy, well, this one is definitely for you. We're going to be unpacking a system called FedThreat-X, and honestly, the research behind it is just incredibly clever.
So think about this for a second. How do you share cyber threat intelligence across entirely different cloud providers without exposing a single raw data log? It's kind of the ultimate paradox in modern cybersecurity, right? I mean, we all know that to catch advanced adversaries, we absolutely have to see the big picture. But at the same time, strict data privacy laws and confidentiality rules mean we literally cannot pull all our sensitive data together in one place. It is a massive hurdle. And it's exactly the problem FedThreat-X was built to solve.
Okay, let's take a quick look at our roadmap for today. We'll start with the multi-cloud privacy paradox, then enter the FedThreat-X framework. After that, we'll check out the performance against baseline models, followed by upgrading daily SOC operations, and wrap up with business benefits and compliance.
Part 1. The multi-cloud privacy paradox.
To really get why this solution is such a game changer, we first have to understand the incredibly fragmented reality of today's cloud telemetry. Modern organizations have, rapidly transitioned to using multiple clouds: AWS, Azure, Google Cloud, private setups. It creates this wildly varied attack surface. Now, historically, we've relied on centralized SIEM systems, which work by sucking all of that data into one giant central hub. But pooling raw, highly sensitive logs from all over the place, that creates absolute compliance nightmares and data residency violations. But on the flip side, if you just keep everything fragmented and isolated in its own little cloud silo, you leave these massive, dangerous blind spots. And guess what? Adversaries know this. They exploit these exact blind spots using cross-cloud lateral movement and coordinated intrusions. They literally just hide in the gaps between your isolated defenses.
Which brings us to part 2. Enter the FedThreat-X framework.
So how do we actually fix this? Well, the researchers are proposing an evolutionary leap using something called federated learning. This bridges the gap beautifully, proving that we don't actually have to choose between having a unified security posture and maintaining strict data privacy. Here is the crucial point. Instead of moving the data to the model, FedThreat-X moves the model to the data. It's totally decentralized. The AI model trains locally right on those diverse cloud nodes. And what gets shared back to the central server? Only the model gradients, or the weights, basically just the mathematical learnings. The raw logs, all that sensitive telemetry with user data and system specifics, are never, ever exposed.
To really picture how this architecture functions, let's use a global hospital analogy. Imagine a network of hospitals all around the world. They all urgently want to learn how to diagnose a brand new disease, but patient privacy laws completely prevent them from sharing actual patient medical records. So, what do? Each hospital learns the symptoms locally using their own secure records. Then they only share that symptom list, which represents our model weights, with a global health organization. That global organization takes everyone's lists, aggregates them to create one master diagnostic tool, and sends that master tool back out to all the hospitals. That is exactly what's happening here with the cloud nodes, local preprocessing, and global server aggregation. The knowledge is shared, but the raw data stays locked down.
But FedThreat-X actually goes a step further than just basic federated learning. It uses this brilliant feature called threat-aware adaptive aggregation. This means the global server doesn't just blindly accept every single update it gets equally. It dynamically assigns weights to each cloud node based on the quality of its data and the reliability of its model. Plus, they throw in proximal stability. In plain English, this just acts like an anchor. It keeps the learning right on track, even when threat distributions vary wildly across all those different clouds, preventing the global model from drifting off course, or worse, being hijacked by adversarial poisoning attacks.
All right, part 3. Performance against baseline models.
Now, I know all of this sounds amazing in theory, right? But we have to see the hard metrics to prove this framework actually works in the wild. The researchers put this to the test on the massive Microsoft Guide dataset. We're talking over 13 million real-world cybersecurity evidence records. And just look at how FedThreat-X absolutely dominates the traditional baseline models. A standard convolutional neural network, or CNN, hits about 94.1% accuracy. A long short-term memory model, the LSTM, reaches 95.2%. But FedThreat-X, it achieves a state-of-the-art 98.7% accuracy. And with an F1 score of 98.7% too, that proves the model is exceptionally balanced.
You might be thinking, okay, a jump from 94 or 95% up to 98.7% accuracy, is that really a huge deal? Absolutely. In the context of processing millions of daily security logs, that is a massive leap. It means drastically fewer false positives. For a security operations center, a false positive is literally just a wasted hour chasing ghosts. So this precision directly translates to significantly less alert fatigue for your analysts. They can finally focus on the actual, real threats.
Looking at the ROC curve data across different incident classes makes this even clearer. See how those lines just sharply climb straight up toward that top left corner? That almost perfect right angle is telling us that FedThreat-X generates highly confident attack estimations. It correctly flags the true threats while keeping the false alarms practically at zero. In a high-stakes, real-world SOC environment, having this level of fidelity isn't just a nice bonus, it is an absolute necessity. We can also really see the model's robustness over time. If we check out the training versus validation curves over 50 epochs of learning, notice how incredibly tightly aligned the training and validation lines are, especially as they converge. This tight alignment is key. It proves the model isn't just blindly memorizing the data, it is actually learning. It doesn't overfit despite the noisy, highly variable reality of multi-cloud telemetry.
Moving on to Part 4, Upgrading Daily SOC Operations.
So we've got the statistical proof, but how does this theoretical framework actually change the day-to-day workflow of a SOC analyst? Well, imagine you're an analyst right on the front lines. Instead of manually hunting and pecking through fragmented logs across 10 different cloud dashboards, this builds a totally automated, real-time pipeline. Step 1. Real-time log streams arrive at the local cloud node. Step 2. A very lightweight, 3-layer neural network locally and instantly processes that data to scan for threats. Step 3. The global FedThreat-X model kicks in to generate a real-time threat score. And finally, Step 4. Only if that score indicates a confirmed true threat, a high-fidelity alert gets forwarded directly to your desk. It is a completely seamless, low-latency workflow that basically replaces the nightmare of manual log hunting.
And honestly, the best part is that when that alert finally does hit your desk, it's not just some random vague noise. The system tells you exactly why it's alerting you. Just look at what FedThreat-X actually prioritizes. The top indicator? MITRE ATTT techniques. The second? Account UPN, which is basically user identities. This means the model is making its decisions based on highly critical behavioral indicators and account anomalies, handing analysts rich, actionable context rather than just throwing up a generic system error warning.
Finally, Part 5, Business Benefits and Compliance.
Now, this whole framework isn't just a win for the tech team, it ties directly into the top priorities of the C-suite. If you're bringing this to leadership, here are your big takeaways. FedThreat-X unifies your threat posture across AWS, Azure, Google, literally wherever you're operating. Because the raw data never ever leaves its original location, it guarantees strict compliance with data residency rules, totally addressing those massive headaches around HIPAA and GDPR. Plus, it dramatically reduces SOC alert fatigue thanks to that incredible 98.7% accuracy rate we talked about. And lastly, that threat-aware weighting means it actively defends itself against bad actors trying to poison the AI. Basically, protecting privacy no longer means you have to sacrifice a unified security posture.
I really want to highlight this quote directly from the researchers themselves. They state, "The outcomes verify that the model is appropriate for real-world SOC operations, where privacy assurances and high detection fidelity are crucial." I am really emphasizing real-world here because it proves FedThreat-X is not just some cool lab experiment. This is a production-ready solution purpose-built for the grueling, everyday realities of enterprise multi-cloud security. Which leaves us with a pretty massive question to consider. If we can now build an impenetrable global defense system using federated intelligence and do it without ever exposing the underlying sensitive data, what excuses are honestly left for maintaining isolated blind spot cybersecurity? The technology to collaborate safely is right here. It's time to completely rethink how we protect the cloud. Thank you so much for joining me for this explainer. I really hope it brought some much-needed clarity to a seriously complex topic. Keep learning and stay secure out there.